These are the notes for 1-5, Rewriting Equations and Formulas. This section can also be referred to as solving literal equations or solving multivariable equations. Let's start with an equation that we're familiar with, or rather, I guess it's a formula. C equals 4t minus 148. We used this formula earlier this year to find the number of cricket chirps in a minute in relation to the air temperature in degrees Fahrenheit. So let's start with, given the number of chirps in a minute, let's find the corresponding temperature. Now I want us to go out and solve and show each step to solving this equation using inverse operations so that we're able to use it to help us understand how to rewrite other formulas. So we're using C equals 4t minus 148. And we're going to substitute the value, C equals 92. So the first step would be to undo the subtraction. So we're subtracting 148, so we want to add 148 to both sides. (92 plus 148 is 240, equals 4 times t. The last step is to undo the multiplication. So right now, remember, we're solving for t, and right now we're multiplying t by 4. So we're going to divide both sides by 4. So I get t equals 60 degrees Fahrenheit. So when we hear 92 chirps in a minute, that means that we can estimate the temperature to be about 60 degrees Fahrenheit. Let's do that again for 58 chirps. Again, we're using the formula 4t minus 148. And we're going to substitute the value c equals 58. Our first step to solve is to undo the subtraction. So we're subtracting 148 from the t term, so we want to add 148 to both sides. (58 plus 148 is 206, and that equals 4 times t. The inverse operation of multiplying by 4 is dividing by 4. So the temperature, when there are 58 chirps in 1 minute, is 51.5 degrees Fahrenheit. So that way, it required us to substitute the value in, but then we had to solve the equation. But if you notice, the steps to solve were the same. First, we added 148, and then we divided by 4. So what we can do is we can rewrite this formula, this cricket chirp formula, so that it's set equal to t. So all we have to do is just substitute the value of t in. Let's give it a try. So we want to rewrite our cricket formula, c equals 4 times t minus 148, and we want to solve it for the variable t. And we're going to use the same steps we used above. So the first step is to undo that subtraction. We want to add 148 to both sides. C plus 148 is just C plus 148. And that equals 4 times t. The next step is to undo the multiplication. And we're multiplying by 4, so we want to divide both sides by 4. And there's our new formula. So t equals, you can write it as C plus 148, all divided by 4, or you can separate it into two terms. C divided by 4 plus 148 divided by 4. Now this can be simplified. 148 divided by 4 is 37. Either form would be considered correct. The second form in blue would just be considered to be more simplified. So now what we want to do is we want to use our new formula. Let's use the simplified one. And we want to find the temperature when there are 20 chirps. So when C equals 20. So T equals 20 divided by 4 plus 37. 20 divided by 4 is 5. And 5 plus 37 is 42. So we were able to create a new formula by using inverse operations so that it was much easier to find the missing temperature. So sometimes, if rearranging an equation with 2 or more variables, it makes it easier to solve. So when we want to isolate the variable, our first step would be to distribute and combine like terms. These are the same steps that we would use to solve equations. Step 2, undo addition, subtraction. Step 3, undo multiplication and division. And you should be left with your solution for the indicated variable if you showed out all of your steps. Now let's put these steps in action. So we're going to rewrite these equations for y. We're going to solve these equations for y. Our first step is we want to add or subtract the x term over so that we can get closer to that y term. With number 4, we're adding 4x, so we're going to subtract 4x. So I have 9y equals negative 4x plus 7. Now I always prefer to keep my x term first, but you could write it as 7 minus 4x if you'd rather do that. So that's how we undo the addition subtraction. Now we want to undo the multiplication. So we're multiplying y by 9. So we want to divide both sides by 9. Now either one of these forms is fine. You never need to do both. So we get y equals negative 4x plus 7 all over 9. Again, we showed out all of our steps, so our answer was right in front of us. If you did it the other way, you would have gotten y equals 7 minus 4x all divided by 9. Now these could also be split up into 2 terms. And you can divide negative 4x by 9 and the 7 by 9. And the same way if you had it the other order. Okay, any one of these options would be this equation solved for the variable y. But let's try to keep the x term first. That will help us be more successful in a future unit. So why not start now? So with number 5, we want to undo addition subtraction. So we are subtracting 2x. So we want to add 2x to both sides. Remember, let's try to keep the x term first. Next step is we would undo the multiplication, so we're going to divide both sides by 2. And there's the equation solved for y. Now in this case, because both the 2x and the 6 are divisible by 2, in this case we would want to split it up into 2 terms so that we're able to simplify. Two x divided by 2 is x. 6 divided by 2 is 3. So if you had 6 plus 2x originally, your final answer would just be y equals 3 plus x. Now let's try to use our knowledge of inverse operations and apply them to other formulas. So remember, first we want to undo addition subtraction. So for number 6, this right now is a temperature conversion formula to go from Celsius to Fahrenheit. We want to rework it and solve the formula for C so that it becomes a Fahrenheit to Celsius formula. The first step is we want to undo addition. So we want to subtract 32 from both sides. F minus 32 is just F minus 32. Now we want to undo the multiplication. Right now we're multiplying by 9/5. So the inverse operation would be to multiply by the reciprocal, which would be 5/9. Now, because we've shown out each step, there is our new formula. Celsius equals 5/9 times the degrees Fahrenheit minus 32. Now let's try working on the area of a triangle formula, number 7. Area equals 1/2 base times height. A equals 1/2 b times h. The first step, let's eliminate that fraction. Let's multiply both sides by 2. Fractions can be daunting, so when you can eliminate them, I think it helps to move forward. 2 times a is 2a equals b times h. And remember, we're solving for h. So right now, what's being done to h is we're multiplying it by b. So to solve, we'll divide by b. And there's our new formula. H equals 2a divided by b. Word problems for this section are just going to be formulas, and then the words are just going to give us context to the formula. So the formula we're going to use is P equals 64 times D plus 2,112. Now what this formula represents is the actual words in the word problem. So if a scuba diver starts at sea level, the pressure on the diver at a depth of D feet is given by that formula. So D is the depth of the diver, how deep the diver is underwater, and P represents the pressure in pounds per square foot. So we first want to solve this formula for D. So remember, first step is to undo addition subtraction. So we're adding 2,112, so we want to subtract 2,112. P minus 2,112 is just P minus 2,112. And this equals 64 times D. Our next step is to undo the multiplication. So our next step is to divide both sides by 64. And because we've shown out each step, our new formula is right in front of us. So D equals P minus 2,112 divided by 64. We can simplify this and split it up into two terms. P divided by 64 minus 2,112 divided by 64. So when we simplify, we get D equals P over 64, and 2,112 divided by 64 is 33. So again, this formula, this version is a little more simplified, but this version in blue is also going to get the job done in terms of finding the depth of the scuba diver. So now we're going to use our formula. Let's use the simplified one. D equals P divided by 64 minus 33. And we're going to find the depth of the scuba diver, how far below sea level that the diver is at when the pressure is 4,032 pounds per square foot. So substitute the value for P into our new formula. $4,032 divided by 64 is 63. And 63 minus 33 is 30. So the depth is 30 feet. This concludes our notes for 1-5, rewriting equations and formulas. If you have any questions, don't hesitate to sign up for an extra help session or to send me an email.